Hi, welcome to Neat Physics Ninja. Today we are going to solve a problem that has to do with centripetal acceleration, the acceleration that a particle or any object undergoes when moving along a circle. Let's first read the problem statement. A particle moves in a circle of radius 5 centimeters with a constant speed and time period 0.2 pi seconds. The acceleration of the particle is. So we're supposed to find what the acceleration of the particle is, and this particle is moving along a circle. So we know what the radius of the circle is. The circle has a radius of 5 centimeters, and so the particle goes along the circle with a constant speed, which means the particle is in uniform circular motion. So what's the acceleration that they're talking about here? It's the centripetal acceleration. So as a particle goes along the circular path, it experiences an acceleration which points towards the center. So this is basically the acceleration that keeps the particle moving along the circle rather than go along a straight line. So from every moment as the particle moves along the circle, the particle changes its velocity in the form of a change in direction, and therefore it's the centripetal acceleration that is causing this change in velocity. So let's find out what the expression is. Also, we are given what the time period is. So time period is the time it requires for the particle to complete one circle, to go once around the circle, and that's given to be 0.2 pi seconds. So the time period is given in the form of a multiple of pi the irrational number. So what's the expression that we are aware of for centripetal acceleration? We are aware of the expression v squared over r. But we cannot use this expression right away because we are not really aware of what the speed of the particle is. We know that the speed is constant, but we don't really know what the value is. So let's see if we can use the given information to and ultimately change this expression to fit it to a form that can be used directly from the given data in the question. So we are aware that the speed of a particle, which is defined as distance over time, can be written as 2 pi r over t. So the 2 pi r here is the distance traveled by the particle while completing one round around the circle, and t is the time required to do that, the time period, which is exactly the time required to complete one circle around the circular path. So let's substitute this expression into the previous expression for the acceleration, and what do we get? We get 2 pi r over t, the whole squared, divided by r. So let's simplify this by squaring. We get 4 pi squared r squared over t squared divided by r. So one of the r's is going to get cancelled, and what we end up with is 4 pi squared r over t squared. Now we have an expression for the centripetal acceleration that is sort of ready to be used in this particular problem, because all that remains here is to substitute the values of the radius of the circular path and t, the time it requires for the particle to complete one circle, both of which we are aware of. Right? So let's plug in the values, and what we get is 4 pi squared. Now the radius is given to be 5 centimeters. If you're going to stick with SI units, we would have to convert that into meters, which is 0.05 meters. and the time period is given to be 0.2 pi seconds. So it's going to be 0.2 pi the whole squared. Simplifying this a bit more, we get 4 pi squared times 0.05 divided by 0.04 times pi squared. So cancelling a few things here, 4 0.01 times, we end up with 0.05 divided by 0.01, which is basically 5. So 5 meter per second squared is the acceleration of the particle. And we have found what the acceleration is. And so what we have basically done is use the given information about the radius of the circular path and the time period, and we have computed the acceleration, the magnitude of the centripetal acceleration of the particle. So it is this acceleration that shows that the particle is going along a circle. Recall that acceleration is the rate of change of velocity. And so as the particle goes around in a circular path, its velocity changes constantly, and so there is that acceleration. So the correct option here is option D, which is 5 meter per second squared. So one thing to be aware of here is that often in problems, firstly we need to be aware of the formulas that are required to solve a given problem. But here, just knowing the expression for centripetal acceleration is not enough. We also need to be able to mold this formula into a form that can be useful in this particular situation, where we are aware of the radius and the time period, but not the speed of the particle right away. We are not given the speed of the particle, so we can't just use the expression or the equation for centripetal acceleration as it is. We'll have to modify it a bit and then plug in the values, right? And we get this particular value, 5 meter per second squared. So that's it for today. See you in the next problem.